Started. Firstly, this presentation is being recorded. I don't actually expect anyone else to be talking but me, but just so you know, if you speak up, you will be recorded, you will be on YouTube forevermore. Some other bits and pieces. If captions would be useful to you, you can find that at the bottom right of your Google Meet client, ellipses, turn on captions. Similarly for screen layout and for if you need to change your video settings, they're all down there somewhere. So hopefully you can find that if you need it. Speaking of video quality issues, my internet has been notoriously unreliable over the last 2 days. So it is possible that at some point I will drop out, but worry not. If that happens, my backup presenter, Robert, is here and will seamlessly take over. You will not even notice a change. But all that said, let's get started. So this is tips and tricks for testing with WPT. Hopefully that is not a surprise to you. If it is, then you need to run and check the schedule because you're in the wrong room. But yeah, so my name's Stephen. I lead the ecosystem infra team at Google. We work on a number of things, but mostly focused around web platform tests, WPT. And as I said, my backup presenter, Robert Ma, is also in the room. So what will I be talking about today? I'm going to give a really brief overview of WPT. Since the presentation is called Tips and Tricks, hopefully you know what it is already, but just in case, I'm going to cover that. I'm going to talk about the difference between run webtest.py and WPT runner, because that's something that trips up a lot of Blink developers. There's differences there, and it really can cause problems. And then the main meat of it is going to be 10 tips and tricks for working with WPT. Finally, there is also a Q&A session, which is happening in the next time slot in breakout room 4. So this is not this room. This is the main room. Breakout room 4 is a different Google Meet. So if you'd like to come along, have a chat, ask any questions about WPT, go check out the schedule, scroll all the way to the right to breakout room 4, and you'll find the link there. The Q&A will not be recorded, so that's definitely the time you can feel free to come in, speak up, ask the silly questions. We'll give some silly answers. It'll be great for everyone. That said, let's get started. So, a brief overview of WPT, or Web Platform Tests. At its core, Web Platform Test is a shared test suite between browser vendors or really anyone who wants to run them. It's a set of tests that hopefully test a good portion of the web platform feature surface, which is, of course, a huge target, and so we definitely don't test all of it. In terms of things we care about, really, it runs in a number of places. It runs in the upstream WPT CI, where we run a bunch of different browsers to get results for lots of different things that we can compare. But it also runs downstream in a number of browser vendors CI. So Chromium, Gecko, and WebKit all run WPT tests as well as a form of testing their own product and making sure that things don't regress and that new features fix problems, that sort of thing. WPT comes with its own test infrastructure that really consists of two main parts. There is a server, WPT serve, that serves up the test files, most of them HTML, but not all of them. And then there is a runner, WPT runner, that manages the sets of tests that you want to run. It controls the running of individual tests, so telling the browser, hey, load this test. And then it also is responsible for gathering and reporting the results from the test. Did it pass? Did it fail? Did it time out? What was the error message? There's a bunch of other auxiliary features to WPT, but I'm not going to talk about them because there's way too many and they really don't matter. Most of the tests in WPT are JavaScript-based, so that's testharness.js. You've probably seen those. Or they're visual comparison tests, so ref tests. Render 2 different HTML files, check that either they match or that they don't match, that sort of thing. Brief note, I am not going to talk about test automation today, so the ability for a test to actually tell the browser to do something outside of the web platform space, that's testdriver.js. Not going to talk about it, way too big a subject, didn't have time. Happy to chat about it in the Q&A if anyone has questions. So, run web tests versus WPT runner. What's all that about? So, in Chromium CI, really the core of the truth is we don't run WPT properly. We only use half of that nice geo I talked about. We run the WPT server, WPT serve, but we don't use WPT runner. Instead, we use our own legacy run webtest.py framework, which takes the job of choosing the test, running individual tests, and reporting results. This is significant. It causes differences in the tests. And so I'm going to go through those quickly here. So for a start, run webtest.py, not surprisingly, is written to be Chromium specific. It only has to work in Chromium CI. It doesn't have to work anywhere else. On the other hand, WPT runner has to work for every browser, so it's much more agnostic. A big difference is that run webtest runs content shell. And not only does it run content shell, but it runs content shell in a test mode that is full of the most ridiculous testing magic you have ever seen. If you've not had the pleasure of diving into content shell's testing mode, don't. It's not worth it. It's really scary in there. WPT runner, on the other hand, runs tests in real Chrome. It does pass some testing flags. It does set some stuff up for testing, but the level of test magic is far lower, and it's much closer to what we ship to our users than Content Shell is. Because Content Shell is so magical, Run Web Test gets to communicate with it using internal APIs. So you've probably seen lots of calls to like internals.foo, internals.bar. What WPT Runner does not have that, that privilege because Chrome doesn't ship those APIs. So instead, WPT Runner communicates with the browser via a standard, the WebDriver spec, and indeed via the Chrome driver implementation of the WebDriver spec. And that means that whenever WPT Runner needs to add a new feature or do something new, we have to spec it. We have to standardize it, and we have to agree on something that all the browsers can do, which has its ups and downs, right? Like everything in the spec world. And finally, on the reporting of results, run web tests use test expectations and expected TXT files. You've probably seen these scattered around Blink if you've ever worked in Blink, to record sort of its baseline expectations. WPT Runner upstream has a different file format, has this ini-like metadata file format. It's a similar idea. They're just a little bit more powerful. They can record a bit more information than a plain text file. And so all of this together really leads to sort of, well, two problems, one of which I've written down here and the other one I forgot to put on the slide. So firstly, not all WPT features work in run web tests. If we add something new to WPT, it doesn't necessarily work unless we also add support in run web tests. The other big difference, which I mentioned earlier, though, is that because we use Content Shell and run web tests and Chrome and WPT Runner, sometimes things work differently. Like those are different browsers, and Content Shell is not Chrome. So there can definitely be, especially with rendering problems, subpixel stuff, there are differences between them. There is a nice internal document, go/run web test is not WPT, which is sadly Googlers only. So I really apologize for the external contributors here, but take a look at that if you're a Googler. So with that down, let's jump into the tips and tricks. Number one, testharness.js subtest types. We're starting with something pretty simple here. Probably everyone already knows this, so I apologize, but there are 3 types of subtests in testharness. There is test. Exactly what it sounds like, the simplest possible thing. You give it a function, it runs the function. Once the function returns, your test is done. If you do any asynchronous work in the function, tough. We don't know about it. It's gone. We don't care. If that fails, it'll just be a harness error because we have no idea. Multiple tests run sequentially because JavaScript is single-threaded, and so since we only care about them, running a function and returning, it's going to be sequential. So what do you do if you do have asynchronous tests, which is pretty common in this day and age? Well, you use promise test or you use async test. Promise test, as the name implies, is all about promises. It expects that you'll return a promise. It awaits that promise before it does anything else. And so as such, it clearly supports async wait. It's really nice for promise-based APIs where you can just chain thens, that sort of things. It can still handle callback functions. So if you want to do something like a request animation frame, there's a neat little trick you can do, which I'll talk about in a later slide. And the final type, I should also mention, promise tests actually also run sequentially. They support asynchronous execution, but each one of them awaits the previous promise test before it starts running. So as long as you are doing things properly with promises, they do not run concurrently, they run sequentially. Leading me to our final type of test, async test, the most powerful subtest in test harness, also the one that you will shoot yourself in the foot with most often. They run entirely concurrently. So obviously JavaScript is single-threaded, but if any of them yield, the next one will just start executing. And also because you are just operating with callback APIs, you now need to do a bunch of fun little calling and passing around of the test object, that T that's being passed in there, to make sure that we know where your asserts are happening, like what test they're for. If you ever forget to t.stepfunc, you'll just get like random rejections where the harness is like, oh crap, you failed an assert, but I have no idea for what test. So that's not great. Also, please remember to mark your test as done as well, because if you forget that, we're just going to time out because we have no idea when you're finished. So 3 types of subtests, tip number 1. Tip number 2, the setup function. This is pretty straightforward. We have a setup function. It's called once before all tests are run. That's not before each test, before all subtests. It takes up to 2 arguments, a function and a property bag. The function is, as you would expect, a function that you can do some setup in. So if you have some really expensive setup for your test file, you can do it once before all the subtests run. The grab bag of properties has a bunch of stuff, some of which you might want to pass, some of which you probably don't. A big one is single test. It essentially tells test harness that you're just going to have one test in this test file. And so you don't need to use subtests, and it reduces a little bit of boilerplate. The other ones, I'll talk about explicit done later. Uncaught exception, hide test state, they're quite niche, so you probably don't care about them that much. And you really don't want to pass output document explicit timeout or timeout multiplier. They're for the CI. Please don't use them unless you really know what you're doing. Tip number 3, avoiding boilerplate. So I'm sure we're all familiar that testharness.js can be pretty boilerplate heavy, right? To write one test, you have to create an HTML file, you have to include 2 scripts, you have to write body and script and all of that. It's a bit ridiculous. You can avoid all of this by using pure JS tests. So if you call your test file something.window.js, we will create that HTML for you. We will include test harness and test harness report for you, and you can just write your test. It's lovely. You can also use meta tags to add more information. So you can add a title, you can add another script that we'll include, or you can add stuff like timeouts. All of these will be translated into things for HTML. And so I really recommend the use of pure JS tests. I think they reduce the boilerplate involved quite a lot. Tip number 4, testing outside the window scope. So this is an extension of pure JS tests for testing in other scopes. And if you don't know what the phrase testing outside the window scope means, you probably don't have to care about this, so don't worry about it. For those of you that do get the fun of dealing with different scopes, you can use 2 other forms of pure JS tests to test in non-window scopes. So .worker.js will load your test in a dedicated worker, and .any.js will actually create multiple versions of your test for different scopes. So one test file, multiple tests. Again, you use this meta thing to choose the scope. So it's this global flag. You give it a comma-separated list of scopes. There are 4 scopes available, the 3 types of workers plus window, or you can use the shorthand worker, which just stands for all 3 workers. In each case, we will load the appropriate type of worker. We'll install your script into the worker, and we'll take care of getting the results back from it. If it matters, you can check what type of test you're currently in using self.global is window and self.global is worker. And no, I have no idea why there's 2 of them when they're just the inversion of each other. Don't ask me. Tip number 5, going back to that thing I said about promise tests. So you're writing a promise test, but you want to test something like add event listener, which gives you a callback. There's no promise here. What do we do? Oh no, Stephen, that means we have to use that stepfunc thing that you talked about. Oh, that's so ugly. And if I forget to use it, I'm going to get an uncaught exception error. Oh, that's so annoying. You don't have to do that. There's a nice little trick where instead of doing that, you can just directly give it the resolve function. So you can wrap the whole thing in a promise, make sure the promise resolves, and then write your asserts. The important part is that by letting the promise resolve, either in an await or by chaining it into a then, we now know what test you're back in. Like you're back in the context of the test. And so we know where you are. So this is a nice way to get around the whole, what do I do about callback APIs? And basically means that you never have to use async test. And I think that's a better world when we don't have to use async test. Number 6, define your subtests in time. What do I mean by this? I mean that it's an uncommon problem, but occasionally people will try and define subtests after an event has happened or after wrath or something like that, and then they just won't show up and people will be like, what happened to my test? The answer is because we're just executing an HTML file, we have to guess it when you're done executing, like defining subtests. And the way we do that by default is just to check for the load event. Once the load event is fired, we're like, cool, you're done. All your tests are defined. We're happy. Which, to be honest, is probably what you should make sure happens, because generating tests dynamically is sort of icky, and it'd be much nicer if you could instead wait for the events inside the subtest. But if you have to do it, you can set that explicit done property that I mentioned. And you can, at that point, we will no longer guess when you're finished. It's up to you. You have to call a top-level done function to say, I'm done defining subtests. There's slightly different behavior for workers. Servers worker, we use the install event because there's no document load event. And in other workers, you need to explicitly call done, unless you're using those neat little pure.js tests I showed you, which will automatically call done for you, again, roughly based on a heuristic of guessing when you're probably done. Tip number 7, what about ref tests? When do screenshots happen? Well, our goal here is to be in a stable state for you to screenshot. So that just means we have to wait for layout in Paint, right? Once initial layout in Paint is done, we're good. But you forget fonts. Fonts are asynchronous. And so that means that if you were just to screenshot when layout in Paint happens, fonts may or may not have happened yet. And so what we actually do is we first wait for document.load, then we wait for fonts, and then we try and work out when Paint has happened, which apparently, as I looked in the code this morning, means we just raf twice and cross our fingers. And most of the time that works. If you need a bit more control, there is a reftest wait class. If you attach this class to your HTML object, we will not screenshot. We just wait. We send you a test rendered event, and the purpose of this is to just let you know that the first rendering has happened. So if you want to do invalidation testing or something like that, you know that a rendering has happened. Whether or not you do anything with the test rendered event, we will just wait until you remove the reftest wait class. And once you remove the reftest wait class, we will, I think, do another layout, another raf, and then we'll screenshot, something like that. But it's useful if you need to, like, do some more complicated operations before you actually do the screenshotting. Tip number 8. Oh, my camera is gone. That's fun. Can other people see my camera? I don't know. Hopefully that fixed it. Tip number 8, fuzzy matching in ref tests. We have reached the first tip that does not work in run web tests. This doesn't work in Chromium today. And that is the ability to have a reference that doesn't have to match exactly. I'm sure, as a lot of people know, especially in the rendering space, it can be sometimes hard to get a reference that actually looks identical to a test. You get anti-aliasing subpixel differences, you get font rendering differences, and sometimes you get specs that are just a little bit loose in what you're allowed to do, and so it's valid to do slightly different renderings. And this is where fuzzy matching comes to the rescue. It's a meta tag you can apply to a ref test. It takes 2 parameters, max difference and total pixels. The max difference is the maximum difference in color for each channel. I don't think you can specify the channels individually. I think it just applies to all of them. I also actually don't know offhand whether it applies to alpha. I assume so. I'm not sure. I'm not a great expert on this. And then total pixels, is the number of pixels that may be different. Note, you can remove the names entirely and just write content equals 10 semicolon 100, just to reduce a bit of that boilerplate there as well. But in this case on the right, these 2 images would match with a fuzzy image diff, but they don't currently in Chromium because we don't support this at all. And oh, thank you, Robert, pointing that out. Yeah, so this doesn't work at all today in Chromium, and if that really gets on your nerves, well, you probably should have yelled at us a long time ago because this has been broken for like ever. But come yell at us. Tip number 9, other types of tests, print-reftests and crashtests. So print-reftests, as the name implies, are ref tests for paged media. They are detected by having print in the file name or being in a print subdirectory, so like foo/print/your test here. They're exactly like a ref test. They support all ref test features, fuzzy matching, etc., except from screenshots are taken in print mode. They have an additional meta, ref test pages, that can choose which pages to compare if you only can care about some of the pages. And they are completely unsupported in run web tests. So again, if you care about this, come yell at us, because currently it's not a thing. Crash tests are, as the name implies, tests that check only for crashes. They are identified by having crash in the file name or being in a crash test subdirectory. So you can see we did a great job of consistency here. You know, real good consistency there. But all crash tests do are wait for the load event, wait for paint, and say you're good. If you crash in the meantime, you fail, otherwise you pass. You can set a test wait class to delay that is identical to ref test wait, but is called something different because consistency. Again, you get a test rendered event if you want to do anything with that. An important sort of point here is you do not need to include testharness.js. You do not need to define a subtest. It's a very common thing we see. The only thing this test type cares about is do you pass or fail? Sorry, do you crash or not, should I say. This one is supported in run web tests. Crash tests do work. And finally, file name flags. So a lot of test behavior can be configured just using the test file name. You can change whether it's loaded over HTTPS, loaded on HTTP2, loaded on the www subdomain, or activate server-side substitution, all just by putting something in your file name. You can also use semantic changes, so you can mark a test as optional or tentative, meaning that optional means that it tests like a may part of a spec rather than a must, and tentative just sort of represents it tests something that we haven't quite landed a spec change for yet, and maybe we're not sure about, but we think it should happen this way. Both of those two, they're purely semantical. They're just sort of, you know, they just inform people. Briefly on server-side substitution, this is a fun little feature that lets us inject values into your code because code injection is fun. Essentially, it's mostly used for cross-domain testing. You can define variables for ports and domains and that sort of thing, and we will inject the correct values for where WPT serve is running so that your test does the right thing. One neat thing is it has these arrays that look, it has these variables that look clearly like they're arrays, but are actually dictionaries, and they support empty keys, which means you get really weird looking variables like domains, empty brackets. And you're just like, what is that? Well, it's actually the lookup of the domains dictionary with an empty key, which is the default domain. These are almost all supported in run web tests. The only one that doesn't work is HTTP2. We've just never bothered to write an HTTP2 server because no one was asking us for it. This shouldn't be that hard, he says, but is not currently supported. And that was 10 tips and tricks for testing with WPT. As I said, there will be a Q&A in the breakout room. I think I'm on time. I don't think I've gone over. I think I'm slightly under, actually. I'm amazed. I am. So in 5 minutes, there will be a Q&A in breakout room 4, which is not this room. So if you want to come talk, please come over to break room 4. But other than that, thank you very much, everyone, for coming to listen. I hope you learned something about WPT.